Okay, so we're looking at circles today, but got to give you kind of a general overview of what a conic section is. Okay. Circles are pretty cool, you know. The wheel was invented a long time ago. It's pretty neat. The conic sections, though, come from what you see on your book, page 623. Basically, you got a cone stacked on a cone. If I could draw this accurately, I'd probably be really cool. But and each one of these shapes that we're going to study comes from slicing that in some direction. So if you took out a knife and you actually had one of these and you swiped across it, you can come up with one of the shapes we're going to study. Okay, it could be, you could cut it this direction, straight and perpendicular. That would make you a circle. Okay, you could cut it at an angle. Okay, that would make us an ellipse. You could cut it that direction, and you would have a hyperbola. Okay, you'll see a hyperbola looks like this. It's two parabolas, right? Stacked, facing different directions. It's exactly the opposite sign of an ellipse. So if you take an ellipse and just, and then you can also do a parabola, okay, by cutting it like so. Okay, so those are the conic sections. Some genius had the idea of relating all these shapes in one method, and that's what they came up with. Okay. As we move along, I think you could also this was presented to me in high school, and honestly, I used the shapes, but where they come from never really mattered to me that much. But history is a great thing to study. It's the one subject that I got a B in school. Yeah. In college, I got a B in History 132, and it destroyed my GPA. Anyways, so like I say, history is important. Get to know it because you can learn from it. Okay. Where we're going to start here, let me see if this looks familiar to you. Does that look familiar? What is it? It is a circle. Look, which one? It's the unit circle because the radius is 1. Okay, so we have studied that quite a bit. It's been the main focus of us for probably a month and a half, right? In order for us to plot things on a coordinate grid, we have to have an equation. If much like, such cute sneezes today. Okay, 1, 2. If I wanted to graph a line, I would have an equation, correct? Okay, well, circles have equations too. It is based on the center, which in our case is 0, 0. It's very easy. Okay, and it's based on the radius as well. That's all you need. Okay. The equation of this circle is that right there. Okay. Notice no longer is it y equals. That's what this chapter brings to light for us. X squareds and y squareds in the same expression. Okay, so is that a function?
No.
Why not? That would work algebraically. What's the definition of a function? Right, no one x value can have two y values. That has two, right? Not a function. Not fun. Although I think it is. Okay, because it does not pass the vertical line test, right? So none of these that we're going to study, except possibly parabolas, are functions. Okay. You can write this as a y equals. Okay, and you will see it a lot. Circles you will see very often in y equals form. So I want you to recognize that. I'm going to subtract the x squared over. You get y squared is 1 minus x squared. And then you square root both sides. And do not forget the positive or negative. Okay. So these are equivalent expressions. All right. So we should be able to graph a circle looking at either way. Okay. This is split. Let's try a different color. No, you. Notice the positive here and the negative. Okay, the positive is just the top. Okay. So if you had just positive root 1 minus x squared, that's all you're looking at is the top half, the top hemisphere. The bottom, the negative here is the bottom. And that completes the circle. Okay. Good. Okay. We're going to move the next one off the center 0, 0. Better change colors here. Graph x minus 2 squared plus y plus 1 squared equals 16. Okay, the last one was just x squared and y squared, right? That's because the center was 0 and 0. So now our center is positive 2, negative 1. Okay. So it's the opposite of what's there. Keep that in mind. And then the radius is the square root of 16, which is 4, because that is r squared. So if you're looking for the general formula, there it is. X minus h squared, y minus k squared, and r squared. Okay? So you pull the data out, throw it on a grid. Everybody good with where I got those numbers? Sweet. None of that. I could say it now. Sugar crash. Okay, there's our center, correct? Don't you carry a box of candy with you? Holy cow. The world is going to end. Okay. And the radius is 4. So 1, 2, 3, 4. 1, 2, 3, 4. 4. And that's 4 right there. And then you can draw your circle. Center 2, -1, and radius 4. Okay. Okay, that's all I'm going to ask you to know for circles. Okay, you might have to apply it. You might have to use the distance formula to calculate the radius length. Okay, some things of that nature. You might have to use the midpoint formula. If you're given 2 points on the circle, 180 degrees apart, you can use the midpoint formula to find the center, correct? Okay, so be aware that 10.1 can be applied to this in circles, so midpoints and distance. On the Google Classroom, how many of you looked at the question I posted? You looked, thank you. Bonus point. Did you answer the question? Okay. I told you yesterday there was a magnitude 7.1 earthquake in Alaska, right? Near where I used to live? Okay. The way that we can locate this epicenter, where that earthquake actually was located, we're doing 3 dimensions with spheres. Okay. We can this is purely informational. Let's say you have, these are seismic stations. Okay. These seismic stations record the time at which the earthquake struck that location. Okay. Based on that time, they can build a circle of possible locations where the earthquake started, because it traveled so fast. Okay. So the earthquake is at this station, this station is different. They have a different radius, right? Maybe this circle is like so if you have 2 stations that register, these are the only 2 possible locations that earthquake. Possible locations. Both stations agree on those spots, right? If you get a third, though, I'm going to attempt to do this as well as we can. Where the LP in the front, all this does is tell you it was directly below you somewhere.
Having problems.